this is basically very important to get correctly. What's our level 2 article? So level 2 /OB access official. Basically, I told myself I'll still account. So why should the OS current development? So you're gonna have something here. So this is it's recording, not it's recording. Basically this video is very important to do. Probably this video is on MMUKO OS textile computing system. Basically one system to build on MMUKO OS is a textile computing system. So this is textile computing. You're gonna the bioware Soverign textile system is basically bioware. Basically you are the controller. How many input produce a textile? So for each have input, you're gonna have a signal. You're gonna be building stuff using first. System computing is, if you have the modeling system, modern like a way of modeling. So it's based on down the two things. So we're gonna look at the lattice calculus polar coding system. Polar coding system. That was the most we're gonna use UniLateral bipartite tripolar consensus decimal maybe system that by tripolar consensus magnetic memory coded color coded coder decoder system via memory model. So go some of the model we make. So to go from ambiguity in what's happening here. A lot is happening here. But I'm gonna put this down laptop near my here. You guys see the feedback. But here it's down that this is one frame building. One entire frame. So the goal is this time that you are not to have the power. You know that I have the power. The 3 points of value is gonna have to have a degree of freedom. So right now it's gonna be a memory model. But it doesn't think about the parents or the group of talent work on the kids. Especially so the title is something. So that Bioware. So if you know Bioware, how can you do Bioware is the biological of firmware. This is the logic of the person the physical control. It doesn't matter what it is, you find out what you know. Finally, they control the system by being biological. The interface. The interface is this is not just they are the signal to the system. They are the control. They're just in the controller. They're the controller, and you control the big arrow up, down, left, and right. So I'm gonna show you the program now. I'm gonna show you how this works in practice. But I'm gonna show you how it does. So I got my control here. So I got this big control here. So I got this file DMD control state. Basically this D file is enables a raw mode and allows you to relay and replay commands to macros. So macros copy and paste. But you can also in macros it was like a macro that can copy and paste. But this is integral logic. This macro is passive. So first one is about x squared plus y squared equals t squared. You can understand that this x squared is the dimensional quantity of a subscript of system. Now we can kind of follow the rules of calculus. Lattice calculus, if I can look at the stuff. And this file, literally is a cat command. Literally, it's a relay system. It's a relay command. So no matter what code you play, you type in a command, chemical down, up, down, left, right, A, B, start. We're telling you what we're saying wrong all the time. But you still could go to code. But Konami code. So up, down, left, right, BA, start or select. So this is basically replayable over stream of bytes. So I want to send this command here. So this kind of file, see what happens. But you're gonna have a system of so you're gonna have you're gonna go to command control and then enter. gonna type generally will see I just copy and pasted it and you place VA dot flex them. It even plays up down. So you gotta press up, down, left, right, up, down, left, right, up, down, left, right. VA start. Now start can be shift and enter. Select the mean. Start can be you press shift and enter. Get root to 10. That's really select. You press enter, press the start. So you're gonna press shift and enter for select and enter. You're going to have to know this how we play. I'm just going to select. So I'm gonna try to enhance with AI to have a command structure. This one I'm coding as the but this one the command to play, you can do that command with a human being. So this is the relay system. The command control is the relay system. It's also really in time. But this is a replay system. It's the command I have. I will call it right. Int main, int pointer to argc, character pointer to rv, colon. I am now in C mode. Hold on. I can use this stuff, and I can use function on the fly. Because it puts new function also pointed them. But we should have a controller separate from the controlling, and with the controller. But the controls are the kind of thing are the signals of this controller basically can have a keyboard controller. You can have system control. It's one of you can hear a keyboard with your hand, or you can have a voice control. But it goes to how to replace them with expert over time to route them. You go to the scanning. Okay. And I do cat, so that's cat got it. This is what it says. This is started to have lots of scanning. See, the scanning can have int main. I am here. I am an echo server. So this is the first approach of echo server. So the server is just replaying the command. It's relaying. I am replaying. After the type enter. I am going to now demonstrate the Konami code. Konami code. So this kind of is kind of special. This is the replay. So you can have I am being watched and while through I stop watching rewrite what you did. So you see you have a sender, a receiver, and you have a broadcaster or verifier. So this let me give you more now. You're gonna have my name. You have my name Namdi. But who is you? I'm trying to call it. So you can use that because are you talking to Chain Namdi? Are you talking to SD Namdi? Are you talking to OBI Namdi? But when I broadcast the channel, I'm saying broadcast the Namdi. So basically I'm speaking to all of them. So channel 3, stage 3 is for broadcast. So G is broadcast to Uche. We mean Uche Namdi. Broadcast LJ. Broadcast Namdi. Well, you're gonna have the standard receiver taken sent to SD from Uche. Just right there. You cannot say the thing is that it is another the kind of process feature of them. Just that keyword. It's not gonna be but that's the problem. The main problem is that the step. We're gonna have a stamp. That is not the only problem. Yeah, you're gonna have this kind of all of this. You're gonna have start and do. So the shift plus 10 plus enter is the select keyword. Well, this is the algorithm about what is this? I don't know whose person is this. I don't know, but I think UPI is too. Yeah, I don't know. Again, MCBM. Well, this is my you find this is my own system. We're gonna look about this thing here. Problems with how to our solutions to obviously configure. So my obviously configure my obviously why this is to calculate this one. So basically, we're gonna read this article out loud with AI stuff, but no, with AI, but no, we're gonna listen to some of it. So it's not gonna be too long, but we're gonna do it how to do it. So just to kind of context. Well, this is textile the textile model. It shows that things are modeled by hand. Anything that's been modeled by hand is like easy to do in the kind of physical way. But this is two articles we want to read. We're gonna read this one here. Open the Microsoft Edge. We're gonna use this one here.
Why your OS should calculate.
Basically, text preferences.
Why your OS should calculate discriminants. How graph theory prevents institutional ghosting and why MMUKO was ## built on physics, not metaphor.
Okay, so it was built on physics and spring theory. So springs are things are often half. So this method is half stance, it is half what? Not stance. It is half, it's no stance. So this kind of if it's half true, it's half fake. If it's half, this is the fault. If it's real, it's fake. If it's half fake, it's half real. If it's a lie, it's true. Etc. This is the polarity concept.
Metaphor. By Nnamdi Okpala Obianexus Computing, February 16, 2026. The problem: your computer doesn't know when systems are about to fail. Every operating system tracks memory, CPU cycles, and disk I/O. None of them track relationship stability. When you send an email to your housing council and get no response for 20 days, your computer doesn't flag this as a system failure, but it is. When Cambridge University promises feedback on your PhD application within 2 weeks and goes silent for 3 months, no software alerts you that the constitutional contract has been violated, but your nervous system certainly knows. This is because traditional operating systems are built on transactional logic. Did the packet arrive? Did the file save? Did the process complete? But governance, whether in housing, academia, healthcare, or any human system, requires relational logic. Is the feedback loop intact? Is mutual accountability maintained? Has the connection between parties degraded into decoherence? This is where discriminants come in. What is a discriminant? The 30-second version. Remember the quadratic formula from high school? $x equals \frac will be \pm \sqrt will be squared for AC to a $. That thing under the square root, delta equals b superscript 2 for AC is the discriminant. It tells you whether your equation has delta 0, 2 real solutions, stable, separable. Delta equals 0, 1 solution, critical points, touching. Delta 0, complex solutions, entangled, requires higher dimensions. Mathematicians use discriminants to classify polynomial roots. Physicists use them to detect phase transitions. Constitutional computers use them to detect when institutions are ghosting you. The insight bipartite.
The operation will sue people for you. This was literally suing people while making money, while you're doing that, while people are paying you. So that's the goal. Go and see your protocol. You got this MMUKO and for my key for like kilo for Bosco. It's choose people for it. That's the very important now. Model.
Bipartite relationships equals two colorable graphs. In graph theory, a bipartite graph is one where vertices can be divided into two sets, U and V, such that every edge connects a vertex in U to a vertex in V. No edges exist within the same set. Key property: bipartite graphs are always two colorable. You can paint every vertex with two colors such that no adjacent vertices share a color. Translation to governance. Set U equals the institution, council, university, employer. Set V equals the citizen, U, the applicant, the worker. Edges equals constitutional obligations, respond to requests, provide feedback, maintain records. A healthy system is bipartite. The institution and the citizen have distinct but coupled roles. When the discriminant goes negative, delta 0, the graph is no longer too colorable. It contains odd length cycles that create conflicts of interest. Example, the housing council that ghosted me. In 2023 to 2025, I submitted multiple requests to my local housing council. Repair requests for unsafe living conditions. Reasonable accommodation paperwork for neurodivergent needs. Freedom of information request for decision-making records. Standard response time per their policy, 20 working days. Actual response time, 60 plus days, often with no response at all. Traditional OS view. Email sent, email delivered, inbox not full, system status, green. Enter full screen mode, exit full screen mode. MMUKO OS view, discriminate tracking. Hashtag bipartite state between citizen, U, and council, or V, power_alpha equals 0.7 hashtag citizens energy, documentation, follow-ups, power_beta equals 0.3 hashtag council's energy, responses, actions, coherence equals SQRT, power_alpha asterisk power_beta, hashtag square root 0.21 is almost equal to 0.458 hashtag calculate discriminate equals coherence asterisk 2 for asterisk power_alpha asterisk power_beta hashtag delta equals 0.21 for 0.7 0.3 equals 0.21. 0.84 is equal to minus 0.63 if discriminate 0. Print, warning bipartite structure compromised. Print, system has entered non-planar state. Print, odd cycle detected. Council is both judge and party. Print, constitutional violation. Escalation required. Enter full screen mode.
That's the small problem. This is one of what it says. This is you just because it's constitutional violation. This is the council. It doesn't mean to validate how it works. It's not about them. It's about us. And that's the constitutional violation. You got a council violation. You got a constitutional violation like my one. So you got you can violate. You're gonna pay for that. You're gonna pay the money. But this might be very because less than 0. It should be less than 0. This is what it always do. It's not because it's not because it's a manual phase. This is a manual phase system. So it's just making system. But this is going to be coherent system. Your coherence operator is going plus or minus plus times one of critical real time. Number theory and number get divided minus. We got to do the same thing for the system. We coherent. But this the minus divide, like to do operations based on the kind of edge that that's essentially what to. This is less than zero. It's good zero is minus one. If it's zero, then you have point of interest. You can have one. But then so what happened? What happened is output.
Enter full screen mode, exit full screen mode. What happened? The council became both the decision maker, you role, and the entity being complained about, the role. The graph stopped being bipartite. The discriminate went negative. This isn't a bureaucratic delay. This is a mathematical phase transition. The physics, discriminants detect decoherence. In quantum mechanics, two particles can be entangled, their states are correlated even across distance. The coherence between them is measured by the off-diagonal element of their density matrix. For a two-state system, like our bipartite graph, $\rho equals \begin matrix 0.7 and \sqrt 0.
Very important stuff. Yeah, the public trust is been done. What they give goes to the current system. The current system. The system, the off-diagonal public trust between them is both of them. So, the stop being independent, the stop taking position, translation. This discussion is different them. So, you no longer have a position. You are having an activity. You have to activate it. So you still have a relationship basically, and that's what matters. So, how to put it in the system. This about the MMUKO that we can show that. And then go to the other one, which is the other one, the in fact built from the world past world. You're gonna have basically all my work is here in this process with one drive live. We took we put it there, and which OneDrive, OpenAccess OneDrive, there should be a link in the description. I'll put that there. This is OneDrive link for this here. Basically, I've just accessed my account, or my GitHub account, so the account /OpenAccess. But figure out how to do work with that. So, how to do the recovery there. Stuff recovery, micro OS, the account of stuff recovery. That's the goal here. Because we're going to be locked out systems here. So go there, we're gonna have to go there. We're gonna have the OneDrive my work in OneDrive here. As the infrastructure, you understand? Now I'm gonna show you something else. So you're before now this account you don't have to log into. But this is practice my reality. And this is basically the last article. So let me go to your fantasy. If I go to read. What is that? What is so loud?
MMUKO OS, your fantasy is my reality, human rights compiled into code. By Nnamdi Michael Okpola, Obianexus Design and Computing Cambridge PhD candidate January 2025. I was forgotten. So I built a system that can't forget.
Yes.
Let me tell you something about being forgotten by systems. Not the romantic kind of forgetting, not, they just overlooked my email. I mean the institutional kind of forgetting that destroys lives. The kind where you're sectioned in a hospital for 8 days when the legal limit is 72 hours, and nobody notices. You call the council about housing violations 47 times, and each time they say, we look.
Basically, you have to violation. You have 8 days. Basically, you are sectioned for I was thinking for 2 days AI basically. This is AI. So this is basically 2 days. Basically you brought people for 1 day, 1 day imprisonment, and they put me in. The other people about they won't having anything. So they are racist to me. But they go to Spain. This article basically is a protocol my studying. Oh, this AI. Anyway, I'm gonna do this one, but let's go here. So this step was wrong. 15 minutes. So I'm gonna end the video now. But this is the video on the Lapis calculus framework. And of course for the system. So finally I can now introduce what I was saying. So what I was saying was, you got this video here, and what I want to introduce was the let me go to my video here. This was introduced was the kind of system of non-polarity. You probably gonna introduce the lateral system. Basically, trying to introduce a textile computer, biological firmware, textile computer. So you can pick up stuff in your computer, but move parts of your computer. Because only the sample the computer is textile. So the textile interface you have. So you allow you to interact with it by moving stuff, moving stuff on the computer board. Or this is not what it is here. You are moving stuff. You can have a feeling of that texture. So you have a biological texture you can have for your hands. So that's what MMUKO is the human rights. It allows you to basically most of the voice systems to build your own. So this article, what this article will do basically, the discriminant system for relationship modeling, textile modeling, and the kind of institutional graph that goes like textile modeling. Obviously, textile means you are doesn't matter we do art and craft, or craft and arts. You're crafting before or you're doing art. You see your textile. You have a textile you're doing by your textile. You're doing by hand. So the goal is to have a textile model for mic, you from like kilo of Oscar dash operating system. Basically, you're allowed to build games with it. The main benefit of having this kind of textile model is you build games with it. The video game is very important. You build it with because video games can be more expressive, but it's the builders tool. Because it's for builders. MMUKO is for builders. People want to build stuff. People who want to work, not people want to build. Yes. Thank you for watching the video. They can use it to work and build. So you can work and build at the same time. So if you want to go past working and start building their own things, but it's still working. So you can use it to work and build and stuff. Thank you for watching the video. Like this for fun. This is basically the video why I made this. So basically, if you go to the start Spain, this is basically a field system. But you're gonna understand because you're gonna have a unilateral system that's bipolar, consensus resolution. 2 poles, but you have tripolar related, but it's basically a system of ensuring that this is rough lang, this is considered close group, this is actually more binding. This is basically binding, both sides of this one. I'm saying you're gonna have that there. Biology for function interface. You're gonna have so you're gonna have all of them unilateral, unilateral means they share one consensus state of a robot ecosystem. The robot is this is a twin model of the biosystem, but it's basically unilateral and tripolar, like me. But it's gonna destroy you have control over the because it's tripolar. You know what you're doing. This is not you put it you have a plane of field, you can pick up the new stuff around it. So it's a unilateral system. Thank you for watching the video, guys. It's easy for